In this lesson, I just wanted to walk through some guidelines for condensing logarithms. Condensing logarithms is important in order to solve logarithmic equations, which we're going to be seeing in the next section. So it's important that we still have a good understanding of those log rules that we saw earlier in this section. If you have any questions on those log rules, I would say to either go back and watch Professor Messenger's video or the other lesson on expanding logarithms. When we are condensing logarithms, think of our order of operations in terms of we want to work inside parentheses first, or parentheses, brackets, braces, whatever we may have. In this case, we can see that we have a square bracket with the 1/3 being multiplied on the outside, and then within the parentheses of each of these natural logs, we have an x plus 6 and then an x squared minus 25. Now it's important to understand that the x plus 6 is attached to that natural log. So we're taking the natural log of x plus 6. That x plus 6 is just going to stay there. Same thing with the x squared minus 25. It is within the natural log since we're taking the natural log of x squared minus 25, so those are going to stay. So when I talk about working inside parentheses or brackets, we're looking at having multiple logs within a set of parentheses or brackets, which we have right now. We have 3 logs within 1 braces. So here, sort of working backwards from what we did with our expanding our logarithms, we first want to use the power rule to bring up any numbers that are in front of individual logs. Okay, so if I look at my first log again, I have 5 natural log of x plus 6. That 5 I'm going to want to bring up as an exponent. So this 1/3 is going to stay. My bracket's going to stay, but the 5 is going to come up so that we have the natural log of x plus 6 raised to the 5th power. Looking at my next log, I have the natural log of x. There's no number in front of the natural log, so there's nothing to do. And then our last one, looking at the natural log of x squared minus 25, there's no number in front, so that also is going to stay the same. So these last 2 logs we don't touch. The only thing that we were able to do in our first step was to bring up that 5 that was in front of that natural log. Our next step is sort of a 2-part step. Essentially what we want to do is we need to look from left to right. So again, I'm still working inside of those square brackets, and we're going to use either our quotient rule to condense 2 logs with subtraction into 1 log with division, or we're going to use our product rule to condense 2 logs with addition into 1 log with multiplication. So looking inside of our brackets, moving left to right, I have 2 logs. The first 2 logs that I see are separated by subtraction. Since those 2 logs are separated by subtraction, we're going to condense just those 2 logs into 1 log with division. So that means we're going to have this 1/3 still on the outside. Then again, remember, it's becoming two logs turn into 1 log. So I'm going to have 1 natural log, and then we're going to make this into our quotient rule. So our first log, that x plus 6 to the 5th, will be our numerator. And then our denominator will be what we got from our second log, which would just be x. So those 2 logs disappear, and using our quotient rule turn into 1 log, which means I still have this plus natural log of x squared minus 25. So when we're looking at this, again, it's important to understand that we started off with the natural log of x plus 6 to the 5th minus the natural log of x. When I condensed it, there's only 1 log. It goes completely on the outside, and then I use the parentheses to show the numerator was x plus 6 to the 5th all over x. So that was our first step. Now again, like I said, the second step kind of has a few parts to it because we do want to move left to right. First, we were able to use the quotient rule, but I can continue to use either the quotient rule or the product rule, and you want to repeat this as many times as necessary, either using your quotient rule or your product rule one at a time, moving left to right. Because if I look at what I have right now, still inside of our brackets, I have 2 logs that are separated by an addition. Well, 2 logs separated by an addition, I can use our product rule, and we can condense it with multiplication. So what we have here then would be the 1/3 still on the outside, natural log of x plus 6 to the 5th all over x, and then times that x squared minus 25. So what happened was we got rid of that second log. Now this isn't exactly the prettiest answer that we have. We do want to make this into one fraction. So remember, when we're multiplying, we have a fraction and a whole number. You could put that whole number, that x squared minus 25, considering to be that whole number part, over 1, and when we multiply it, it actually goes into the numerator. So whenever you have a fraction and you're going to be using your product rule, really what's going to happen, you can shorthand this, is to put, in this case, that x squared minus 25 into the numerator. So that way we have 1/3 natural log of x plus 6 to the 5th, and then that x squared minus 25 will go in the numerator, all over x. So that's what we have right now. For our third step, we want to bring up any remaining numbers that are in front of natural logs or logs using our power rule. So again, we started off using our power rule, and now we're going to be closing out with using our power rule. If you look at how I rewrote our answer from the previous slide, what I did was I got rid of the brackets that were around the natural log, which is perfectly fine since we had completely condensed what was inside. This way you can see that that 1/3 is being multiplied by the natural log, which means that we can bring it up. And remember, again, to save yourself time, you can say that you have the natural log of the whole inside raised to the 1/3, but a 1/3 exponent does mean that it's going to be a cube root. So we're keeping this as the natural log of the cube root of our x plus 6 to the 5th, x squared minus 25, all over x. And that would be our condensed form. So again, remember that the natural log is still on the outside of that root, or whatever the exponent happens to be. Our very last step would be to try to simplify and reduce if possible. The only thing that I could do here would be to factor that x squared minus 25. So I would have x plus 6 to the 5th. And then x squared minus 25 will become x plus 5, x minus 5, all over x. So although I can factor it, really what we have here cannot be simplified anymore. So either of these two answers would be fine. Again, the important piece in terms of bringing up that last exponent using the power rule is that the natural log has to be on the outside.